All right, good evening. We're going to take a look at exponential functions once again. They're still going to have the form y equals a times b to the power of x. This time, though, we're going to look at decay. And you have a decay exponential function. Our a value is still going to be greater than 0. And our b value is going to be between 0 and 1. So when you have a b value between 0 and 1, not including 0 or 1, we're going to have a decay. For our first function, for 3 on that worksheet we looked at today, our a value is 4 and the b value is 1/2. Once again, that b value of 1/2 indicates that we are going to have a decay. So we're going to create our table and we're using the same x values, -2, -1, 0, 1, and 2, to substitute in for x and simplify. So this equals 4 times 1/2 raised to the power of -2. Now when you raise a fraction to a negative exponent, you can flip the reciprocal, so find the reciprocal of the fraction, and then your exponent will be positive. So this is really 2 to the power of +2, or 2 over 1, which you can just write it as 2. So that equals 4 times 4, which equals 16. So our y value is 16. Right, now we have when x is -1, so we have y equals 4 times 1/2 to the power of -1. Once again, that -1 will flip to find the reciprocal, so that will equal 2, so it equals 8. When x is 0, we get 4 times 1/2 raised to the power of 0. Anything raised to the power of 0 is 1, so that equals 4. When x is 1, we get so when x is 1, we get 4 times 1/2 raised to the power of 1. Anything raised to the power of 1 is just what it is. That will be 1/2. 4 times 1/2 is 2. And then when x is 2, we get 4 times 1/2 raised to the power of 2, which equals 4 times 1. So we have 1/2 times 1/2. 1 times 1 is 1. 2 times 2 is 4. So 4 times 1/4 is 1. So we have our points. So -2, 16, -1, 8, 0, 4, and then 1, 2, and 2, 1. So once again, we're going to draw a smooth curve to connect our points there. Now I do want to go ahead and identify our asymptote, and once again our asymptote is the line that our exponential function approaches but doesn't quite touch, and for this it's on our x-axis, so it's y equals 0, and it's the same setup of what we looked at yesterday and today in class. You can think of that as a plus 0. So any value you're adding or subtracting will be your asymptote. All right. Our end behavior, as x approaches -infinity, this time y will approach positive infinity. And on the flip, as x approaches positive infinity, y will approach 0. So it's slightly different for this particular, for decay. And if we notice the shape is the same as growth, it's just reverse, it's flipped. So that's going to be common there. So that shape will be different. So as our x value approaches positive infinity, our y value is getting smaller. It's approaching that 0 value. All right, so for 2, a is b, or 4, number 4, it's on your worksheet, and b is 1/2. Once again, that 1/2 indicates that we have an exponential decay. And we're going to use the same x and y values. So what I want you to do is to get some practice writing these tables. I want you to hit pause and then find the corresponding y values and then come back. All right, welcome back. So here, when x is -2, we get 1/2 raised to the power of -2, which will give us 4. 4 times 2 is 8. 1/2 raised to the power of -1 is 2. 2 times 2 is 4. 1/2 raised to the power of 0 is 1. 2 times 1 is 2. 1/2 raised to the power of 1 is 1/2. 1/2 times 2 is 1. 1/2 raised to the power of 2 is 1/4. 1/4 times 2 is 1/2, or 0.5. So we're plotting those points, -2, 8, -1, 4, 0, 2, 1, 1, and then 2 and 1/2. And once again, we fully extend to meet the parameters of the graph. Now, one thing I want to mention, as you're increasing up, especially for number 4, we don't have a point very high up. So you're going to have to make sure that as you draw up, you're showing that that exponential growth is going outwards, not straight up, but giving it that curve. Our asymptote here, once again, it's that value we're adding or subtracting, and since we're not adding or subtracting anything, our asymptote is y equals 0. Once again, that has to be an equation, not just a point. That's our asymptote. And our end behavior is going to be the same as number 3. So this is the same. So as x approaches negative infinity, y is approaching infinity, and as x approaches positive infinity, our y value is approaching value is 0. All right, let's take a look at our last problem. All right, our last one we're going to take a look at is number 6 from your worksheet today. So here we're going to have a few different things that are going to come up, so I want to make sure we look over that particular problem. We still have a decay. Our a value is 2, and our, I don't know what's coming up with that, and our b value is 1/2. So once again, that b value of being between 0 and 1 indicates a decay. Now here though, we have a +2, so our asymptote is going to be different here. We still have the same x and y values, or x values, not y values, those will change. So we have -2, -1, 0, 1, and 2. So we're going to walk through finding some of the y values together, and then I want you to take a moment to compute the rest of them. So for number 6, if we substitute in -2 in for x, that gives us 2 times 1/2 raised to the power of -2 plus 1 plus 2, which equals 2 times 1/2 raised to the power -2 plus 1 is -1 plus 2. And with these problems, the biggest key is to make sure you go step by step so that you don't make a mistake. So be cautious with those. 1/2 raised to the power of -1. Keep in mind it flips, so that's 2 plus 2. So that equals 4 plus 2, which equals 6. That will be 6. All right, I want you to pause and compute the rest of them, and then we'll come back together. All right, so the chart's filled out. So we have -2, 6, -1, 4, 0, 3, 1, 2.5, and then 2, 2.25. All right, so here, if we notice, we're approaching the y value, or that line y equals 2, but we're never quite touching it. So that's our asymptote. So smooth line. And so our asymptote is the line y equals 2. And once again, that's a value we're adding or subtracting here, and it's reflected in the graph. Our end behavior, as x approaches negative infinity, y approaches positive infinity, and then as x approaches positive infinity, y approaches 2. All right, so tomorrow we'll be doing more practice with growth and decay functions. And once again, it's all based on that b value. If your b value is between 0 and 1, you have decay. And if your b value is greater than 1, we'll have growth. So on 5, we had a growth function, and that's when you completed in class, because that b value is 2. It's greater than 1. Hope you have a great evening.